Welcome everybody. This is a picture of the cover of a book that I recently wrote. Today, when we talk about the book, I'll use the word we a lot because I had a lot of help with the book, especially Anne Levine, who laid out the book and did a lot of good editing with me, and Lise Stuntz, the publisher and the director of the Creative Learning Exchange. You see that web address there. And so she helped a lot as well. So when I say we, I generally mean those three. And Joan's already talked about all the help I had along the way. I was working in my last job as a mentor and a helper at a high school, and they were interested in moving from some traditional science curriculum where issues are separated, as you see on this graphic, to develop an environmental systems curriculum. And an environmental systems curriculum would be more this way, where the different parts of the environment were looked at all together, and what's happening where they intersect. If you see the little square there, and it's kind of Venn diagram type of diagram, that's where a lot of the important stuff in environmental systems happens. And then thinking more, taking that little center and calling that an environmental systems curriculum, it struck me and my colleagues that environmental systems is part of an even larger system where you see social justice, public health, economic prosperity. There are others, but those are three of the really important social issues that all influence and are influenced by environmental systems. So what Joan has helped me with on these slides, the pictures or ideas that are taken directly from the book Now What, Joan has helped put in the page numbers. So as we go along, if there's something that interests you and you don't want to wait, let's say for looking again at a slide on the recording, and if I go too fast and you wish you could see it more, just mark down what the pages are there and you can look them up if you have the book or a colleague has the book. There's so many different influences on interdisciplinary teaching. I know when I was a teacher myself, I mostly taught elementary and middle school, and I always thought that it would be nearly impossible in a high school to have interdisciplinary learning. And I heard a principal once say in a workshop that interdisciplinary learning in high school would have to come within individual classrooms if we continued the structure that we have now. And that made a big impression on me. And so as when I was a mentor, I would try to help science teachers look at the influences that you see around this circle, and conversely, or also to have the language teachers have students learn to read articles critically, to have history and social studies teachers look at some of the science and the math that's involved, to have kids understand graphing and other ideas like that. So the interdisciplinary considerations have always been very important to me, and it had a large influence on my developing the environmental curriculum. At the same time, as Joan said, I have a specialty now thanks to Waters and Waters Center and other experiences that I had in learning systems principles. So in the book, I tried to amalgamate some of the different systems principles that I learned along the way. And this is kind of a collection. It includes ideas from the Waters habits. Many of you are familiar with the habits of a systems thinker. The systems thinking skills developed by Barry Richmond. Barry Richmond was a huge influence on my learning. Some of Jay Forrester's principles. Jay Forrester was the the founder of system dynamics and associated fields, a brilliant man, and Draper Kaufman, who wrote an influential book years ago called Systems One. So this is this is a collection of some of the ideas from those thinkers who influenced me. I think they're probably pretty familiar to most of you. And when students are faced with complexity and teachers are faced with teaching students about complexity, these are very important to remember. If solutions were simple, they would probably already have been implemented. And even if we assume that people have a good intent and honorable intent, then these systems principles work to make things very difficult to solve. In this webinar, I'll be going over these tools and how we've used them. We may not get to much detail in all of these, but we'll see if we can get an example for each one. These icons were developed by Anne Levine, whom I mentioned earlier, and they appear in the book Now What? So if you have a favorite or you're most comfortable with some of these tools and you look in the table of contents in the appendix, you can find out which of the activities use which of these tools. There's also some modeling, computer modeling. We're not getting into that in this webinar today. I will show some global examples, the big picture environmental topics, and those appear mostly in the book Now What? And then I'll show some examples from the high school where I worked. It's called Innovation Academy Charter School in Massachusetts, United States. So behavior over time graphs. There's a 4-question format that we use often in developing it with students, and it's something good for all of us to remember, I think, when we look at behavior over time graphs. I assume everybody understands behavior over time graphs. Just quickly, if you've never heard of them, they're line graphs that show a variable over time, and traditionally the line goes from left to right, and the time is along the x or horizontal axis. So the behavior over time graphs show us what's changing. We choose a variable, it can be multiple variables or one variable. Second question would be, how is it changing? What's the slope, the trajectory? What's happening? What is the change? The third question talks about the structures and causes that are driving the behavior. Why is it changing? The fourth question then asks, so what and now what? And that's where I got the title for my book. What's the significance of what you're learning, and what are you going to do about it? The question of what the graph doesn't tell you is also very important, and that's one important component of asking good questions. Now, I put good in quotation marks there because we all know the story. There's no dumb questions, but I think there are, excellent questions, and it's important to think about what are we trying to find out, what don't we know, and what should we try to find out. So here's a graph from the book that I printed from the U.S. Energy Information. This is the United States energy consumption from different sources, and you can see the lines showing what's going on here. Coal consumption is the blue lines going way down. Nuclear is kind of holding steady there, the yellow. The one that a lot of us would like to see go up, the total renewable energy, is going up, but at a fairly slow rate. And the two highest lines, are gas and petroleum, natural gas and petroleum. And here's California, where we see at the bottom line here what solar power can be generated in the middle of the day. Of course, the sun is at the highest angle. And so this is called a duck curve, an interesting curve there. So here's the blue line is the total load that's needed, and what makes the duck's belly is the solar energy that fills in part of this curve, and then it disappears later on. Now, here's an example from the high school where I work. The students go to a nearby beach twice and do some research. They measure the beach and also do some online research. So this shows a summer and a winter beach. The summer, this is at the end of the summer on the left here in October. And then this is in April after the winter's done damage to the beach. So this is the East Coast, and along the East Coast we get hurricanes and storms that come up called nor'easters. The wind comes from the northeast when a low pressure system comes up and pushes the sand over the course of the winter, so that it has to be rebuilt by the waves in the summer. And here's the beach over time, and you can see the lines of different years noted on your screen. And no matter what humans do, there's going to be sand erosion. And so over time, again, in the Northeast here, these beaches that face in the direction this one does, which is basically east and northeast, the sand migrates from north down to south, no matter what humans do. And we'll come back to some of the kids' conclusions when we get to the next one. But I wanted to turn it over a little bit to the audience here and just ask what behavior over time graph would interest you in this situation, thinking of different roles you might have if you were a homeowner, an environmentalist, a town planner, and so on, about the beach. So here's a picture of the beaches. These are where, the homeowners have their homes. And we have this kind of behavior over time graph of where the sand is. What other behavior over time would be interesting to you as one of these, having one of these roles? So you can put those in the chat. Joan, you want to say anything about the procedure there for people to have their say?
Realized I was muted there. If people just type into chat, they're coming in now. Heat mapping, flooding levels. Rashida said heat mapping and said flooding levels. Fluctuations in wind patterns, water temperature. So if you look over in chat, I'm reading off of chat here. Predicted sea level rise, surf level. So these are all the things that are coming into chat, Al. Lots of different possibilities.
Great. Yeah, there's a lot of different things too. One of the things that's been changing is the insurance coverage that homeowners are able to get. And it's one thing if you are living in a kind of precarious spot, but if your house is insured or not, that makes a big difference. The number of houses that actually have been washed away, things like that. What's been going on here over time?
And for people who have been in chat, there's also been a question about people are interested in the page references that have shown up, and they were interested in where the recording will appear. And so Sherry is Water Center Events, by the way. Sherry has put the information that we will send a notice to participants when the recording becomes available, that when the recording becomes available, it'll be housed on the Water Center YouTube channel. So people can kind of sit back and relax now, that we'll let you know when it becomes available. And proceed, Al.
Okay, thanks. Thank you. All right. The next tool that I'm going to talk about is a pair of tools, connection circles and causal loop diagrams. And we have an example here. This was from the sketch that I did, and it was from a New York Times article that I read about how the government in Poland was using a variety of initiatives to encourage people to trade up from coal stoves to cleaner natural gas stoves or electric stoves. And so I put some of the variables around the circle and drew some connections around there, and put this in the book as an example of how students can read an article with an eye toward what some of the feedback going on in the article is. So you can see some of these connections in this one. The government has a program for cleaner fuel that will cause more furnace replacements, reducing smog, reducing, they hope, the health problems and fires. And when people see that that's a successful program, there will be more support for the government program, causing a reinforcing loop, a kind of virtuous cycle of getting things cleaner. The education of young people over here is a really small loop, but an important one of getting more public support, teaching young people in schools and in other programs as they grow to look for clean energy sources. And here's a causal loop diagram about how new technologies are used. The support for them goes up. Well, there's more need for them. The support goes up. Available energy from renewable sources should go up. Reliance on fossil fuels should go down. Reducing CO2, improving the health of the environment, and again, then there wouldn't be as big a need. It would reduce the need for new technologies. Joan also said that some of the folks in the webinar today may use an S and O instead of these polarity arrows. Here I have a negative arrow, meaning it goes in the different direction, the opposite direction. So as more CO2 is released, health goes down. As less CO2 is released, health would go up. So that's an opposite. So you may be used to putting an O there for opposite. So in this talk, when I have some brief examples, if you see these polarity arrows, plus is the same as same for some people who use that. So back to the students in the beach, they learned that there was a technique called rip wrap, and you see that over here, rip wrap. And what that is humans building like a pier or some structure out into the water so that the waves are deflected and wouldn't erode the sand in front of your beach if you were a homeowner. And it turns out that from the big picture idea, the riprap works against some of the goals that it has. So when there's armoring with riprap around a shoreline, energy is increased in the rocks, and the turbulence increases in the water. So in other words, building something out into the water causes it to increase the intensity of the waves flooding increases and beach erosion actually increases. It may at first be down the way from your own house, but eventually it's eroding the whole beach. There's more property damage, and then people have to kind of assess whether putting those ripraps is a good thing or not. And so the student who did this connection circle, it's actually more a causal loop already, simplified it to say that the more beach erosion, the more building of man-made structures, and the more building of man-made structures, the more beach erosion. So it's an unintended consequence, the opposite of what people would really want to have happen. And here's one that a lot of people in the webinar have more experience with than I, but this talks about the water in the Rio Grande. And this connection circle shows the influences on the water, as you can see, and what climate change is doing to those influences. Now, this is a rather incomplete connection circle, and I wanted to show some examples about how doing things in an iterative process, revising, is very important in using our systems tools. So let me show you the next slide as well here. Taking the causal loop diagram, you see the two notes in gray there, that climate change has no arrows going back in. So this diagram doesn't show any feedback going back to climate change. And there's no arrows coming out here. So there's no feedback being produced in this diagram from the state of how much water there is in the Rio Grande and in the basin around it. Now, in almost every academic exercise, like writing, doing math problems, science experiments, we expect students to do an iterative process. And I think with systems tools, we need really to make sure we have the same standard. And so we wanted to ask, again, how can we close this loop? And Joan, again, is going to facilitate here and help us with people having the idea of, given this loop, and climate change is causing the growing season to get longer, needing more irrigation. There's more prosperity if people can do that. Population increases. All these things are having the overall use of water increase, reducing the water in the Rio Grande. Climate change is affecting summer rainfall. That affects the water in the Rio Grande. As temperatures rising, snow precipitation and creating a snowpack up in the mountains is being reduced as well. What feedback then could we be adding to this diagram? Joan, any comments or?
And you can either raise your hand, or you can type something into chat. I see from Carlos, from water in Rio Grande to climate change. And he is recommending a minus on that arrowhead. Thank you, Carlos.
What might the water crisis, if we call it that, in the Rio Grande and Rio Grande Basin have? What might that cause people to do that might feed back to other parts of the diagram?
So is your implication in that question that it might be not a direct but there might be something else like, from water in Rio Grande to something else to then climate change. Is that the implication in your question, Al?
Well, there may be an influence if there's less water in the Rio Grande um, that continues to cause some sort of desertification. Is that the word? Causing more desert area, and that causes climate change to be exacerbated. That might be what Carlos is getting at.
Amy has written in less water available, less population. Oh, if that were only true. I live in the desert Southwest and people just keep moving here and there's already not water. Oh, there's an editorial comment. Sorry, I'll just read what's showing up in chat.
Go for it.
Also impact in irrigation, Carlos writes, thank you. We've got a little
Okay.
train of exchanges here going on in chat. Thank you. Danelle writes, conserve water, more rainwater harvesting. Conserve water, Danelle has with a question mark. Maybe affects immigration. Okay, Zoha writes, time delay, exclamation point. Maybe in the future, less population. And then the question is, how long of a time delay will that be? Will that be, again, I'm speaking from a desert Southwest population center.
Yeah, interesting. We have found often, it's difficult to close causal loops, not only in real life, but in, the diagram phase here. And sometimes helping students to do that is asking, what action, if you're at a dead end, let's say, what action would happen after that? And it sounds like the people in the chat are coming up with a number of pathways of what might happen after that.
And we have another comment. I think it more affects the distribution of population rather than making it quote unquote less.
Great.
I actually was just talking to someone yesterday who lives in North Carolina in the United States. And she was saying she's not really happy living there. She's thinking of moving someplace else. And what I said to her, she has 2 young children. I said, well, when you're considering a move, because she just wanted to get out of where she is, I said, consider moving somewhere where there is water. And we'll be anticipating there being water in the future. She goes, oh, that's something I had never thought of. Bernice writes, overall degradation of the environment with less crops able to grow, more dust and contamination in the air, reduced health of residents. I read an article that pollution, the conjecture is that pollution is affecting the concept, they're thinking that pollution is affecting the long-term effects of COVID. Where there's more pollution, the effects of COVID is looking to be worse.
Right. Okay. Well, I think we'll move ahead. A lot of good answers there. Good suggestions. Many of you may be familiar with the systems archetypes, and I have an example here as I can explain one. An archetype is a common feedback loop that we see that can cross platforms. In other words, it can show up in a lot of different places. So the generic one here, this is called drifting goals or eroding goals. The generic one is that there's some kind of a gap in what a certain population want to achieve, and the gains toward that, we use B as just a group here. The net gains increase the activity that they do, and the gap starts to be closed. However, gaps are difficult to close, so there's pressure to lower it. The goal is lowered, and the gap gets worse in that perception. So an example that we use in Now What is the CO2 concentration. And so we can take actions to reduce CO2 in the atmosphere, and it will reduce CO2 in the atmosphere with time delays, of course. And then the concentration would go down and the gap would get smaller. But it's really hard. And also, there's short-term pain involved, of course. And so the pressure to lower the goal causes the target to be lowered. Examples being, all these conventions that happen every few years, and nations coming up with their goals, and then the goals seeming to kind of slide away until the next convention for most countries. And then the gap gets worse. So that's an example of one archetype. And I would say that in the appendix of Now What, there's a lot of information about systems tools, and there's a whole list of the archetype templates, and that's available at the Creative Learning Exchange website. You don't have to buy the book to use the appendix, so that's could be useful for folks at the webinar here. There's a template included. The little diagram is up in the corner for students to look at again, and then some blanks for them to fill in, considering the problem that they're, or the story as we call it, that they're dealing with. One that we used, we had an exposition of student work, which we call Dynamic Quest, until COVID has caused us to put it on hold for a couple of years, where students would come and show the work that they're doing with systems thinking and system dynamics. And then in the afternoon, we'd put the students in groups and have them work on some problem. And working with some adults, teachers, and system dynamicists and systems thinkers, they worked on the problem of the rainforest. And in the rainforest, the area of the rainforest is under extreme pressure, as you know, partly because of the need for agricultural land and people wanting to make profits from that. So here we have the two competing loops, and you recognize the archetype there, that the same area is being competed over, and you have these competing loops. One of the people who want to halt the destruction of the rainforest, allow regrowth, and the other, the people who want to use more agricultural land. The iceberg would be the next diagram. A lot of you might be familiar with an iceberg. This is a 3-level iceberg with the mental models along the side. Some of you may use a 4-level one with mental models at the bottom, or even a 5-level one with another level below that. But this is one from our book where it talks about global carbon emissions, top level being, the events that are seen, and then under the water, the patterns. There's behavior over time graph of carbon emissions and different structures that are causing those emissions, the gas use of fossil fuels. And here's a stock and flow diagram of car sales and road construction. And the mental model that's driving a lot of this, especially in the United States here, I believe that owning and driving my own car is a human right. And here's a sketched out one about global warming, quite similar, so I won't go into that very much. Here the mental model along the side. Global warming causes extreme weather events to increase in frequency and strength. So when we see fire, storms, coral bleaching, drought, other environmental issues like that, the root cause of those is this global warming and climate change. And again, there's a template there for using the iceberg. And real quick before we get to the end, I want to show a quick stock and flow. I know that's sometimes intimidating for people. Here's something that a fifth grade teacher drew in our school, and she was here's a kind of computer model looking stock flow of water in a bathtub. The inflow of water going in and the amount of water in the bathtub is called the stock. There's an outflow of water flowing out. So she gave this template to the students. They could write on top of the pipes what the inflow and outflow might be, and write on the tub what the stock is. And so here's a quick storytelling to take a very complicated problem. CO2 in the atmosphere. CO2 is being produced, being removed. As more carbon fuel is being burned, we're increasing the stock of CO2 from the emissions. That inflow ends up in the atmosphere. Down here we have, as the atmospheric heat is increasing, the outflow of heat radiating to space is slowing down because of the atmospheric blanket holding heat in more. And then students can look at a diagram like that and say, okay, where can we put some leverage points? Where can we apply leverage to change this situation? Planning.
Al, I
Yes,
have a
go ahead.
question. If you can
Yeah.
go back to that stock flow, because you have, it's only 9:40 or 12:40 for you.
Yep.
Have you used this stock flow with students?
Yes, we have,
And
especially in that afternoon dynamic quest activities. Yeah.
mhm. And so what do the students do with this stock flow?
This was used after a climate summit. A lot of people are familiar with the MIT developed climate summit where students do role playing, and it's sort of like the Paris or the Glasgow climate summit. And afterward, or beforehand, but usually afterward, we show the students how reducing CO2 is one of the things that humans need to really get on to now to combat climate change. And so when they make their deals among nations about reducing emissions, about reforestation, about other strategies to reduce CO2 in the atmosphere, this gives them a way to understand how a climate model might work.
So do they build the stock flow out beyond this skeleton, or
I have two experiences with this. One is in a large group where they build this as a kind of group model building, and it turns out to be without equations. It would be like this in
Sure.
just as a diagram. In a science class, the teacher would, especially if they're teaching computer modeling, would help the students put equations in, put quantities in, and run the models. And then a third way, actually, and there are a lot of these models available online. There are models where the guts of it, the mechanisms are more or less hidden, and people use sliders or
oh yeah.
means to put in how much CO2 is being
Mhm.
emitted and what the temperature is going to end up.
Great, thanks.
Yeah. And here's the planning sheet. It's a kind of a flow chart for kids. This is in the book, and haven't seen too much. I haven't seen any examples of this yet. We're hoping that as teachers and administrators and other educators use our book, we'll get some examples of this. And I have a hope that we'll be sharing this, and I'll show this in a slide coming up here. So what we try to do with kids is say, you're studying the environment. Let's look at also the connections to social justice, public health, economic prosperity, and any other social systems that you feel are interacting with the environmental systems. I also would like to, on the publisher's website, help to keep Now What current. The book was published before the war in Ukraine, and that's one example there for sure of how the energy sources are a large part of the conflict there. The oil money that's being used actually on both sides, but particularly for weapons.
Amy, I see your hand raised. Is that a recent hand raise, or is that left from before?
No, it's recent.
Okay.
Yep.
I was curious with that planning sheet. I liked it. I was wondering if it was used before kind of researching, before investigating an issue. Do you do like have the kids investigate an issue and do some of the systems tools and then use the planning tool to discuss leverage, or would you use the planning sheet first and then kind of go into some of the systems tools to research the issue?
Personally, for me, this is kind of a reverse engineering. I have never used this. I was involved in, the high school, as I said, working for a few years, and students were doing projects there. So when I wrote the book this past year or two with my colleagues, we developed this planning sheet. And so since the book's just come out and the planning sheet has just come out, we haven't used this specific one. However, students did, use a similar structure where they would think of a problem, come up against a problem, and we would always urge them to find out to get some sort of a reference mode, either with behavior over time graphs, just some diagrams that they could get from their research, and figure out what are the structures that are happening down there, the bottom box, and then start to think what could they do about it, or what could people do about it, and what actions. So the simple answer to your question is that I don't have experience yet. We've just started this document. We have some experience with students doing projects for sure, and using systems tools. So for example, there was one that I don't know how much time we have here, but some students in a chemistry class were interested in the problem of addiction. Many of them had it personally touched their families or their close friends, and we worked on finding out why addiction was rising, where some of the problems were, and what were the stock flow diagrams that they could look at to see where the flow of drugs were, where the actual leverage points might be to stop that.
Okay, thank you.
And if I could interject, looking at, the way the arrows flow through the project planning document, I just have this thought that, you start with an issue of concern, and then you go trends, system structure, and those are levels of the iceberg, so the second level is on the iceberg is the the patterns level, which could be the same as trends. And then the next level down on the iceberg is the system structure. And then on the planning sheet, it's leverage and action. And those are, kind of like going down the iceberg. On the outside of the iceberg is, as you go down the iceberg, you find where the leverage is. And then going back to your planning sheet, it's action. Well, that's action is the top level of the ladder of inference, which in the iceberg that I'm familiar with, mental models level, the ladder is down there. And so I see a lot of similarities between the planning sheet and the iceberg. Is just a thought that I have.
Yeah, exactly. It was very influential in the way that we decided to lay that out.
Oh, and Ann says, exactly, Joan. Hi, Ann. Okay. They're also
Great,
there
that's
to show
great.
that a project is iterative. Exactly, which, Ann, from when we worked together, that was one thing we didn't like about the visual of the iceberg, is that the visual of the iceberg makes it look like the iceberg is static rather than dynamic. And on you go, Al.
Yeah, so I wanted to kind of sum up by saying now what a call to action. It wouldn't have been very fair to write a book like this and then not give some suggestions for some pathways. And here are some of the suggestions that we had. What can you do? And we certainly don't want, with all the bad news there is, to beat kids down. We want them to be our future leaders and help us solve problems. So keep on learning. Use prior knowledge to find out more. And information is power. It's difficult to now get the real story, but try to follow current events through reliable media. Act locally and improve the environmental systems that are in your community. Join groups that are doing things that you're interested in. Political action, we have to have people vote as soon as they're eligible and make sure that their voting rights are protected. Support candidates who share your concerns. Lifestyle choices. I know in the high school, the kids would do energy audits in their own homes, and they would keep track of how much energy they were using, where there are areas where they were wasting energy or could use it more efficiently. And finally, it's important to be optimistic in the sense that enjoying the beauties, the gifts of the environment and appreciating it will have a positive attitude that we hope can rub off on others and help them appreciate the earth and protect it. We would like to have invite people to share things. We have the Creative Learning Exchange is the publisher. It's a nonprofit and has been a clearinghouse for systems resources for many years. A lot of free resources available as well as things for sale. So if you try out any of the ideas, whether they're related to the book or not at all, we would like to share them and have people use them. So we have just a few minutes, I guess, for questions, right, Joan?
Yes, absolutely.
Well,
So
go
yes,
back to
you've
that,
gone
so.
on to a couple of minutes for questions for Al before we
Or
wrap up.
comments people have, sure.
Danelle, do you want to speak or shall we?
Sure. No, I just put in the chat, and I know that Al has been involved with the Climate Literacy and Energy Awareness Network, but they're a super active group that's doing work related to climate and energy and environmental teaching. And so I would assume people on here, if you haven't heard of it, you should definitely check out their stuff too. And they have a very, very active group that meets every Tuesday to talk about these kinds of things.
Right, and their acronym is CLEAN, right? Danelle?
Yeah.
Yeah.
Mm-hmm. I do just have a question though. I'm curious how you introduce this to students. I mean, is this like their first, as you go through your book, or is that like their first introduction to those tools, or do you introduce them in some other way initially?
Right. It's interesting that the school where I worked, Innovation Academy, is one of the leading systems thinking schools, certainly on the East Coast. And so it's part of the charter. It's a public school, but it's a charter school. And part of the charter is to use systems thinking and system dynamics. So the school does introduce it in across the curriculum. But it's not anybody who's worked with these tools and trying to get systems going knows it's usually not a linear process. So for some students, it's the first time they're using some of the tools. For most students, they're pretty familiar with behavior over time graphs. The other ones, possibly they've used some of them, but we try to introduce a little bit more rigor in the science courses. So we're working on that. My longtime colleague, Rob Quadden, who's a wonderful educator and systems thinker and system dynamicist, is also working at the school, and he's a math teacher and has been trying to increase the amount of computer modeling and computer modeling literacy that the students have through his math course as well. So I usually assume that students are newcomers when we do this, except for behavior over time graphs.
Carlos has his hand raised. Carlos, if you want to ask or speak.
Yes, just a quick comment about mental models. In my opinion, is one of the actions with highest leverage, and yet it at the same time is the most difficult to achieve. What's your experience in trying to influence changing mental models in your students?
Yeah, students tend to be very opinionated, whether they have a lot of information or not, probably like a lot of the rest of us. It's difficult. I think, again, using the graphs as best we can to really say to the kids, what are you seeing in the graph? What is this saying? What are the data telling us? Another thing we try to do is when students do the tools like connection circles and causal loop diagrams, we try to challenge them on the arrows, and we'll say, why are you saying that a change in this variable creates a similar or opposite change in this other variable? Where are you getting that information? Is that just speculation you have? Is it an opinion? Or do you have information? Do you have data? Have you experienced it? Have you read it? I think, as I said earlier in the talk, sometimes we accept that if a student is using a systems tool, that's a good thing, and I agree. But we should also, be willing to press them on it and say, can you show us why you're making that statement? Yeah, the mental models are really important, and I think surfacing them is important as well. Getting students to share them and to tell them.
Thank you, Alan.
I want to point out that there are a number of powerful comments in the chat that I want to point out, and I'll loop back to if we don't get to them right now. For people who aren't familiar with chat, if you want to save your chat, because there have been some links to other organizations or websites, if you want to save your chat, the dots to the bottom right, you can click on that to save your chat. So do that if you're interested. Al, if you could advance the slides here. First of all, I want to thank Al so much for sharing his his time and his expertise for writing the book in the first place, and then coming and putting the slides together. As we've said, we will make this recording available and let you know when it is available on the YouTube channel. And thank you all for being here and interacting with Al and each other in the chat. Thank you, everybody, for being here. If you have to take off,